So we'll start with chapter 2 exercises. And actually the first one I think is chapter 1, which we did previous day, but this is the one that occurred to me is pretty important. And I included it here under chapter 2. So which atomic orbitals overlap to form carbon-oxygen bond shown below? And here you also have an arrow pointing to carbon-oxygen bond. There is only one carbon-oxygen bond, so there should be no doubt which bond it is, but just in case here is arrow pointing at that bond. So what you have to do is actually find hybridization of each of the atoms that form that bond, and then those are the atomic orbitals. So on carbon, this would be an open-ended question. So on an exam, you would have to type up the answer. And there would be space, and here is how you would type it up. So you would say carbon. This doesn't have to be capital, may or may not be. And then you look at this carbon atom. What kind of carbon atom this is? This is carbon atom that forms one double bond and three single bonds. That's sp2 hybridized carbon atom. And we can use a column to separate it. So obviously carbon atom could be sp, sp2, or sp3 hybridized. And it's sp2 hybrid orbital of carbon. So to form these bonds, carbon is forming three sp2 hybrid orbitals. One is used for bond to oxygen, and two are for bonds to two other carbons. And this unhybridized p orbital of carbon is used to form pi bonds, which is part of the double carbon-carbon double bond, one sigma and one pi. So three sigma bonds, three single bonds, sigma bonds are formed from carbon sp2 orbitals. And in case of oxygen, oxygen has no pi bonds on this atom. This atom forms no pi bonds, and there are no p orbitals, like positive charge or anything like that. So that means that oxygen is sp3 hybridized. Remember, hybridization is sp3 minus, that is 3 minus, number of pi and p orbitals. And so this one has to be sp3. So on the test, you can simply type it up like this. Now, properly, two should be superscript, and 3 also should be superscript. And if you really want to be pedantic, sp, those designations of orbitals, should be in italics. But in Canvas is not Word. You do have commands where you can do all of these things, but don't do them because don't waste your time. You would have to go through menu, and exam time is limited. So on the test, if you were to provide answer like this, you would get full points. This would be typically 10 points question, and that's how you would provide that. So this would be, as I said, don't waste your time formatting your answers, formatting it properly. So I will assume when you type something up, simply use everything ordinary font, and I will assume that you know what should be italic or superscript or subscript. So that was question number 1. Question number 2. This is actually where now we are starting with nomenclature or naming of organic compounds. So name the following compound. I just drew this one at random. I hope I don't have too many carbon atoms. This is obviously an alkane. There are no functional groups. For this first test, you need to know nomenclature of alkanes very well, because of course you'll be dealing with nomenclature all throughout this course. And nomenclature of alkanes forms the basis for nomenclature of all other compounds. So nomenclature of alkanes starts by naming the longest chain. So you have to identify the longest chain. Often students make a mistake and assume that this chain, this zigzag chain that is represented horizontally, is the longest. And if you count the numbers, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 carbons. That would be nonane. But actually there is a longer chain, and that's this one. So you have to look for other ways and make sure that there is no longer chain. So if you start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is decane. So root of the name or parent chain is decane, 10 carbons. By the way, you have to memorize actually first 10. That's why I was worried, since I drew it at random without counting, that I may have too many carbon atoms, because if it's more than 10, I don't expect you to memorize more than 10, undecane and dodecane and so on. Undecane would be 11, dodecane 12. So decane, so the longest chain has 10 carbon atoms. Now, substituents should get the smallest possible set of numbers. Or actually, we can name substituents first. So if this is longest chain, then what are the substituents? Well, this is one substituent, 2 carbons, that's ethyl group. And these substituents are 1 carbon substituents methyl groups, and there are 2 of them. Substituents are listed alphabetically. So this is 2 methyls, it's dimethyl. But when we alphabetize substituents, we ignore prefixes that indicate a number of substituents, like di, tri, tetra. So this is ethyl versus methyl. So ethyl is listed first. So it's ethyl, and then dimethyl. That's because methyl comes after ethyl alphabetically. And it should be lowercase. Don't make mistake of assuming that this is a substituent. Sometimes students correctly identify the longest chain, but then revert back to this zigzag chain represented horizontally and look for substituents on that chain. Not very common mistake, but I have seen it happen. So if this is the longest chain, then what are the substituents? And now, so what are substituents on that chain? Now, you need to assign smallest possible set of numbers to substituent, which means you number chain from left to right and right to left, and see which one gives you the smallest possible set of numbers. So let's try from left to right. It should be 1, 2, 3, 4. So ethyl would be 4. We separate number from rest of the name by a dash. So ethyl would be 4, 5, 6, 7. And since there are 2 methyl groups on carbon 7, it will be 7, 7 dash. So we'll separate numbers from each other by a comma. So that's one possible name. 4-ethyl 7,7-dimethyl decane. And actually there is no space here. Alternative is from right to left. So we'll have to change these numbers. So let's go from right to left. So 1, 2, 3, 4. So since there are 2 of them, that's 4,4-dimethyl. If prefix is di, that calls for 2 numbers. So prefix di must be associated with 2 numbers. Tri with 3, tetra with 4, and so on. Okay, let's go to ethyl. So it's 4, 5, 6, 7. So which one is smaller set of numbers? To figure out smallest set of numbers, you add them up. So 4 plus 7 plus 7. And so this would be 18 in this case. In the other case, it would be 7 plus 4 plus 4, or total of 15. 15 is smaller set of numbers. And that means that's correct. So that's the only one that would give you 10 points. Okay, let's try this. Okay. Put a little space between different questions. Okay, first let me check if there are any questions about this. Okay, somebody asked before, how do I know previous one is SP2? I don't know if that was a question before I explained that or not. Um, uh, in the textbook, actually, there is a formula. First, if you went through whole process of determining hybridization, uh, it's explained in textbook on pages 14 to about 24, 25. And then formula for hybridization is given on page 27. sp3 minus number of pi bonds and p orbitals. And there are also various examples given. So that's where you would find that information. So page 27. Any other questions? Okay, let's go to question or exercise 3. So 2-methyl-4-pentanol is an incorrect name for a compound. What is its correct name? This is one of the reasons, previous question too, why you must have pen and paper with you. And I take that into account when determining time for the exam, that you may need to redraw the formula or draw a formula or write a name and so on before you type up the answer. In this case, you have incorrect name for a compound. Just because name is incorrect, it doesn't mean that you cannot draw that formula. Yes, name is incorrect, but it belongs to only one compound. There is only one 2-methyl-4-pentanol. It's a wrong name, but there is only one compound that corresponds to that name. And so what you should do is draw that. So from this name, you draw a formula first. So that's the first step. And I already did it. Well, actually, let's see. No. Yeah, too many overlapping windows. Again, I keep on getting that message. Okay, let me draw it quickly. So okay, so this may be a little bit slow. Okay, so this is, see, if you draw that, this is 1, 2, so 2-methyl, 3, 4, 4-pentanol. So 2-methyl, 4-pentanol. And now you should name it. So you simply, now you forget about this name and simply name this. So 1, 2, 3, 4, 5 carbons. So and it's alcohol. So yes, it is pentanol. But OH group must have the smallest possible number. Now you're not looking for a smallest set of numbers or anything else like that. You are looking for the smallest number to give to the OH group. And that's number 2. 1, 2. So this is 2-pentanol. So 2-pentanol. And then if this is 1, 2, then this methyl group is on carbon 3, 4. So this is 4-methyl. It's 4-methyl, 2-pentanol. And that's correct. Name, and so that would give you 10 points. So these Actually, these three are typical kind of write-in questions. And as you can see, when it comes to write-in questions, Canvas calls them essay questions. You're not really writing an essay. You're just typing up a short answer. It does require maybe sometimes quite a bit of work on your part, but it's a short answer. Next one is an illustration of kind of stuff you have to memorize. So some of these names are names of the compounds like phenol, and in this case, aniline, that you have to memorize. There is no rule to apply or anything like that. Some compounds have names that are assigned to them that you simply have to memorize. It's like foreign language, where you have to memorize. If you're learning a foreign language, there is a lot of vocabulary that you simply have to memorize. There is no way around it. Question number 5. Which of the following alkanes does not have a tertiary carbon atom? So you need to know what is primary, secondary, tertiary, quaternary carbon atom. Primary carbon atom is carbon atom that is bonded to one other carbon atom. Also, methyl group, where you have carbon atom that is not bonded to any other carbon atoms, is also considered to be primary. It's special case, and sometimes we consider it separately and just call it methyl group, separate from primary. But if we group everything together, then methyl and carbon bonded to one other carbon atom is primary. Carbon atom bonded to two other carbons is secondary, to three other carbon atoms tertiary, and to four other carbon atoms is quaternary. So which of the following alkanes does not have tertiary carbon atom? The best way to do it is really to draw them, because trying to figure out from a name and kind of imagine what they would look like could result in a mistake. So I already drew them, and here they are. So they are A, B, C, and D, from left to right. So compound A is 2,3-dimethyl pentane. I'm drawing everything as line formulas. Those formulas are easiest, the fastest to draw, but you should be familiar with those formulas. You should know how to draw them, because if you don't, that could be a concern. Okay, so we are looking for carbon atom, for tertiary carbon atom. That's carbon atom that is bonded to three other carbon atoms. And we are looking for a compound that does not have such a carbon atom. So first A, 2,3-dimethylpentane. See, this carbon 2 is bonded to three other carbons. And also carbon 3. So this one, not only this one has tertiary carbon atom, this one has two tertiary carbon atoms. And by the way, there wouldn't be three questions like this. Oh yeah, this is correct answer because I asked for tertiary carbon atom. This one has two, so that's the one. No, here you have two tertiary. So one or more. Okay. How about next one? 2-methyl, 1-pentanol. Well, this 2-methyl, second carbon, that one is tertiary because that's carbon atom bonded to three others. Next one, 3,3-dimethyl. This one actually does not. This is primary carbon atom bonded only to one other. This one is secondary, bonded to two others. This one is quaternary, bonded to four others. And then again, secondary, primary. So that's correct answer. And finally, D, 2-methyl, 2-pentanol. This carbon atom bonded to oxygen is 1, 2, 3. So that's tertiary. This tertiary carbon atom, it also classifies this alcohol as tertiary alcohol. Question could have been, in terms of alcohols, which one is, let's say, tertiary alcohol? This one with tertiary alcohol, because carbon atom bonded to oxygen is tertiary. This one is primary alcohol, because carbon atom bonded to oxygen is primary. Alcohols could be primary, secondary, tertiary. Again, I hope you covered that. This is actually, oh yeah, yes, this is actually at the intersection of chapters 2 and 3. Because we're looking already at properties. And then question number 6, and then I will check if there are any questions from you. The following compound is and then primary, secondary, tertiary, quaternary. This would be an example of multiple choice question. And so here you have nitrogen, so that's amine. Amines are classified with respect to substitution on nitrogen, not on carbon. So we are looking, is this nitrogen primary, secondary, tertiary, or quaternary? So is nitrogen bonded to one other carbon atom? That's the primary. Two other carbon atoms. Well, this is carbon atom and this is carbon atom. Two carbon atoms. Secondary. So that's correct answer. Secondary. And then three carbon atoms will be tertiary. Four carbon atoms, that will be quaternary ammonium salt, or you would just classify that as quaternary. So correct answer is B, secondary. Okay, so let's check if there are any questions. So for number 5, a carbon bond to methyl counts as if it were bond to another carbon. Yeah, you're just looking at carbon atom. You're not looking what else is bonded to that carbon atom. You're looking at one carbon atom and how many other carbon atoms that is bonded to. But what those other carbon atoms are bonded to is irrelevant. You're simply, for each carbon atom, you simply look how many other carbon atoms it is bonded to. Okay, so let's go back to exercises. Oh, okay. So now we are getting to chapter 3, and I planned chapter 3 to do a break and then chapter 3. So I think that's, let me see if I could think of anything else. Okay, not really. Let me first stop recording here.